All right, so we have been solving quadratic equations throughout this chapter, and we've learned several ways to do this. If we think about the methods we've used, we have solved with square roots. That's when we're in vertex form. We have solved by factoring. We have completed the square. And our latest one, we can solve with the quadratic formula. So if you get your choice on which one to solve, it honestly just depends on what the equation is. One of these methods will be easier depending on the equation you're looking at. So if we want to solve with square roots vertex form, I think that's the easiest one. We can complete the square to get it into vertex form. So let's consider, would it make sense to complete the square? I'm going to put a question mark. I'm just going to explore this idea for a second and see if this is a good method. When we complete the square, that minus 20, we would add to both sides to get it to the other side of our equal sign. We notice there's a number in front of our x squared, so we would factor that out. So we would have 6 times x squared, because if we factor a 6 out of this term, now this is the part that's going to have us pause here for a second. Can we factor a 6 out of a negative 7? And because we can't, this method, completing the square, is just going to be more challenging than it needs to be. So we won't complete the square, and that's because of the specific terms we had here. Had this been a 6x, 12x, 18x, something that 6 could be factored out of, completing the square would be a great method. How about factoring? So factoring, you need everything on one side. 6x squared minus 7x minus 20. It needs to be set equal to 0 in order to factor. There is no GCF for the whole trinomial. You always want to be looking for that. So let's factor this. There is a number in front of the x squared, a equals 6. So I can't just find factors of negative 20 that add up to negative 7. This is the longer factoring. Your options are to guess and check or to use the grouping method. I'm just going to go ahead and review that grouping method again. To solve by factoring using the grouping method, if you remember, we multiply a times c. I'll write this over on the left. 6 times negative 20 is negative 120. And now we're going to look for factors of negative 120 that equals negative 7. So if you just start dividing, finding your factors, we're going to find that 8 fits in 15 times. 8 times 15 is 120. We need it to multiply to a negative 120. So we need one of our factors to be negative, and we want it to add up to a negative 7. So that's going to mean we want the 15 to be negative, because 8 plus negative 15 is negative 7. All right, so we'll continue our work. We have 6x squared. We're going to replace this negative 7x with these two factors. We'll say plus 8x minus 7x, and then minus 20 equals 0. Let's take out a common factor, or greatest common factor here. We can factor out a 4x. That leaves, no, we can't factor out a 4x. Just kidding. We can factor out a 2x. That leaves us with 3x plus 4. Whatever your middle sign is, let's carry that down. So minus, and then what can we factor out of? Oh, did you guys catch my mistake? Do you guys see how I have a minus 7x? Because I had circled that and I said we're going to replace it with these factors. This should be a negative 15x. So minus 15x. Okay. Sorry about that. Hope you guys are using pencil, or maybe you caught my mistake and you didn't even write down that random 7x I was writing down. Okay, so middle sign of minus still comes down. GCF of these two terms is going to be a 5. What we want to notice is because we brought down the negative sign, we're actually factoring out a negative 5. So if you factor a negative 5 out of a negative 15, you get a positive 3x. If you factor a negative 5 out of a negative 20, you get a positive 4. How do we know if we're doing this right so far? Your parentheses match. So we know that we're about to get the right answer. That 3x plus 4 goes into one parenthesis. The other parenthesis is going to be the 2x, the minus 5, kind of the leftovers right there, equals 0. Once it's factored, set each factor equal to 0. So we're going to say 3x plus 4 equals 0. 2x minus 5 equals 0, and we're going to solve. We will get fractions on these two answers. So on this one, we'll subtract 4. 3x equals negative 4. Divide both sides by 3, and x is a negative 4/3. Over on this equation, let's add 5. 2x equals 5. Divide both sides by 2, and you get 5 halves. So there's our solution. It did say to use two different methods and then kind of talk about if there's a preference between the two. So here's our list of our options over here. Solving with square roots, we need vertex form. You can complete the square to get vertex form, but completing the square was going to be more of a headache than it was worth in this example. So we tried factoring and we got that to work. So the other method we're going to use is the quadratic formula. As long as we have standard form, we can use the quadratic formula. I'm going to go ahead and rewrite our function over here. We have 6x squared minus 7x minus 20 equals 0. All right, so let's do that quadratic formula one more time. We start by identifying the a, b, and c. So a is in front of the x squared at 6. B is in front of the x, which is a negative 7, and c is the term on the end. All right, so x equals negative b, so negative 7 plus or minus the square root of b squared minus 4ac. So here's b squared minus 4 times a times c all over 2a. When we simplify, the negative 7 turns to a positive 7 plus or minus the square root. Grab your calculator, use all of those parentheses. That's the only way you're going to get the right number underneath the square root. That is a 529 when we type that in, all over 12. Now, I don't know anything about 529, but I'm going to test it. I'm going to see, can we square root of 529? Maybe it's a perfect square. When you take the square root of 529, we actually find that the square root of 529 is 23, all over 12. Now, we are going to be, okay, let me do this first. So we have two answers. One of them is 7 plus 23 divided by 12. The other one is 7 minus 23 divided by 12. That's what we're doing on our other quadratic formula video. Now we're able to continue simplifying this because this 7 is a like term with this 23. There's not a square root there anymore. So 7 plus 23 is 30 over 12. 30 over 12, we can divide both of those numbers by 6 and we get 5 halves. 7 minus 23 is negative 16 over 12. Negative 16 over 12, if we divide those both by 4, we will get a negative 4/3. So there are our two solutions. You can see that it's the exact same thing that we got from factoring. So how do they compare? Factoring can be efficient, you know, especially if that didn't have a 6 in front and that was just an x squared, and we notice, oh, that's factorable. Factoring's pretty quick. Quadratic formula can be longer. You can't factor everything though. So if you notice it's not factorable, then you would want to choose a solving method that you could use. Quadratic formula works on everything. It doesn't have to, it doesn't have to be easier in some way or another. It will just always work. It will always be this amount of work, but we'll always get the answer with the quadratic formula.